This is Cameron Chai from AZOM.com, and I'm talking to John Guerin from Micromeritics, and he's going to tell us about their ACCUPY 2 1340.
Hi. The ACCUPY 1340 is the newest line in our pycnometer series, pycnometers that are measuring density, true density, by gas displacement. The ACCUPY has two chambers inside the system, one where a sample is placed. This is an example of our 10 cc sample cup. We also have a 1 cc sample chamber and a 100 cc sample chamber into which the sample can be placed. In fact, we have custom designed these for a number of needs that people express in sizes that fit the particular sample sizes that they require. The ACCUPY has its own built-in microprocessor, or it can be controlled from a PC. If you are controlling it from a PC, we've got all the ability to collect the data here and report it. Just to show you a little bit of how the instrument is designed, this is a schematic representation of what you saw previously looking at the instrument. This is the sample chamber with a cap for it, and what is called an expansion valve, expansion chamber. Essentially, we connect pressurized gas, admit it through a fill valve, and pressurize the sample to a user-specified pressure, record that pressure with a transducer, open a valve and permit the gas to expand into this expansion chamber. The pressure drops and we record that second pressure. And then we permit the gas to expel through an exhaust valve. This cycle gives us the ability to look at, using the ideal gas law, the volume of gas displaced by a sample in the sample chamber. We're able to do this because we have calibrated the sample chamber and the expansion chamber with NIST traceable calibration spheres. Once those known spheres are entered and analyzed, the microprocessor records the sample chamber and expansion chamber and stores those for future unknown sample measurements. The instrument can be controlled via the keypad here, so that you can start an analysis by simply pressing the Analyze button, entering a sample identification and a sample mass. What the instrument is really measuring is the volume of gas displaced by a sample. If I know the mass of the sample, then the instrument can calculate true density based upon that. If you look at the software, we have the same ability to do all of those things in a sample file, but we have a lot more flexibility for information about the sample, the analysis conditions, and then many different report possibilities once we have collected data. And here's an example of the raw collected data where we have stored the different pressure cycles, the volume that we have calculated displaced by the sample, and the temperatures of those analyses. In a generated result, this is what one could expect. Sample volume average from a number of tests and the standard deviation, and the sample density average and standard deviation from a number of tests. If we looked at the number of tests in this case, there were 10 replicates done, where we looked at the volume and density and deviations for each of those tests, the elapsed time, and the temperature. And again, at the bottom, we're seeing the average volume and average density for those 10 replicate tests. In this particular example, we've got a plot of volume versus the number of tests, as well as density versus the number of tests. And this is what you're seeing in both of these is the actual test points of each of the 10 replicates and the average value for these tests. So, this is the kind of data that one can get from this instrument. We can look at powders, we can analyze solids, we can analyze slurries, and frequently people are interested in the percent solids in a slurry. That can easily be analyzed with the ACCUPY. Additionally, the ACCUPY instrument, this is the instrument with the built-in microprocessor, as I said. You can actually connect up to 5 additional analytical units, so it's about this big, to this unit, so that you can have the throughput of 6 independent sample stations. Those can either be controlled from the pycnometer with the microprocessor or from the computer, from the PC.
And what's the typical time it takes to take a measurement with the 1340?
The 1340 is very flexible in terms of the number of tests that you will perform. In the example that you saw here, 10 tests, probably less than 30 minutes. A lot of times people in a quality environment want to get a quick result for production control, and you can do 1 or 2 tests and have it done in under 5 minutes.
And what sort of industries would employ such a machine?
You know, it can be used in a lot of different industries. Our 1cc pycnometers with very small volumes are very important to people in the pharmaceutical industry, pharmaceutical R&D. They're working with precious quantities of materials where there's not a lot available. But beyond that, it can go into all types of geological, ceramic, minerals, you name it. There are a lot of different industries that need to know a true or skeletal density of their material at some point in the process.
All right, John, and if anybody wants any more information, they can go to your site.
www.micromeritics.com.
All right, John, thanks for telling us about the ACCUPY 2 1340.
You bet. Thank you.